half of this recording. This will make no sense. Go back and watch the first half immediately before you watch this one. Alright, so we made a big breakthrough in the last recording where we got our final row, C row 0011, and so we have zeros in all of these spots now. And now it's going to be time to finish off the B row. We're going to do the B row, and we want to get a 0 in this spot, the 4. We want that 4 to become a 0, and then we'll be done with the B row. So, fortunately, we just developed a powerful tool to deal with that. And here's how it's going to work. We're just going to take that B row, and we're going to add the C row, the C2 row, our newest row, the C2 row, and we're just going to multiply that C2 row by whatever it takes to get rid of the 4. And it's going to be a negative 4. So negative 4 C2, this is our B1 row, and that's going to be our B2 row. Okay, I hope you can see that that is just really nifty. Alright, B1 is 0, negative 19, 4, and 42. Now, our newest C row, C2 times negative 4, 0 times negative 4 is 0, 0 times negative 4 is 0, 1 times negative 4 is negative 4, and then negative 4. And now we can add 0 plus 0 is 0, negative 19, 0, that's what we wanted, and 42 minus 4 is 38. Now, when we were doing the C2 row, at this point we divided, and we got a really simple looking final line there. We're going to do that again. We're going to just trust, I don't know, negative 19, 38, can that divide evenly? Well, let's try it on our calculator. So we'll divide each term by negative 19, and we do it. We get 0 divided by negative 19, of course, is 0. Negative 19 divided by negative 19 is 1. 0 again, and then 38 divided by negative 19, this is the moment of truth, and we get negative 2. It works. It comes out nice and neat. So let's write that one in here. 0, 1, 0, negative 2. Now that's really nifty. But let's not stop there. Remember we said we were saving ourselves time later on when we put that 0 in the A row there. So we did. We saved ourselves time. Now all we need to do is get rid of that negative 3, and the A row is done also. So we're going to take the A row, just like we did before, A1, and we're going to add whatever it takes to get rid of that negative 3 without messing up the 0 that's already there. And we have that B row that will do the trick. So that B2 row, if we multiply it by 3, that will give us something to counteract the negative 3 in the middle position, and it won't mess up the 0 in the third spot, and that will become our new A row, A2. Alright, so let's do it. 7, negative 3, 0, 27. Multiplying B2 by 3, we get 3 times 0 is 0, 3 times 1 is 3, 3 times 0 is 0, 3 times negative 2 is negative 6. Add them together. And then notice, if we just divide by 7, it's going to make this look so much neater. 1, 0, 0, 3. We could fill that in our last line of our matrix, and we're done. Now, what does this mean? Why did we do all that? What does that tell us? Well, remember where the matrix came from. First of all, everything we've been doing has been legal. We're allowed to do these things with matrices. And so, remember that where this came from, these were just the coefficients of x, y, and z, and then the red line indicated the equal sign. So we could say this is 1x plus 0y plus 0z equals 3, 0x plus 1y plus 0z equals negative 2, 0x plus 0y plus 1z equals 1. And notice in each case we have two zeros, 0y, 0z, cancels out, 1x equals 3. 0x, 0z cancels out, 1y equals negative 2. 0x, 0y cancels out, 1z equals 1. And those are the answers. We can write them like this: x equals 3, y equals negative 2, z equals 1. We can put it in an ordered pair: 3, negative 2, 1, however you like. Those are both fine ways to write your answers. And that's the way you use these to solve problems. Now, long method, much more appropriate to program a computer to do this, because it's very simple operations: adding, subtracting, multiplying, a little bit of dividing. And notice we didn't end up with any fractions unless there were fractions in the final answer, which there were not. So this is a really good method. Let's just go back to the original problem here, just for fun. So in the original problem we had 3 equations, and what we're trying to find out is values for x, y, and z that make all 3 true. I will just pick one of them just to try. So I'm going to let's take that second one. So 2x plus 3y minus 2z equals negative 2. Well, 2 times 3 is 6. 3 times negative 2 is negative 6. Negative 2 times 1 is negative 2. I think you can see 6 minus 6 is 0. Minus 2 is negative 2. Equals negative 2. That's true. And if we plug those values, x is 3, y is negative 2, and z is 1, into the other 2 equations, we would find those ones work as well. So that's how you do this one. Thank you so much for watching, and have a good day.